Well, you guys know that I have a YouTube channel. Had the channel for about 8 years now, I think, something like that. And I had no plans to monetize it at all originally. I was just like doing it for fun, doing it for my classes. But then it got to a point where like my wife wants to work less and stuff. So I thought maybe I should try monetizing it. And so I did. It's not like I make a ton of money from it. I monetized it about starting almost 3 years ago. And at first I was getting $2 or $3 a day. Now I'm up to about $6 a day. Maybe average about 1,500 views. And so what that translates to is you get about $4 for every 1,000 views. At least that's the way it works out for me. I don't know that it's the same for everybody. But I was thinking, based on what we did on Wednesday, talking about the relationship between derivatives and integrals, that it would be a cool thing for me to show you how the relationship between derivatives and integrals is something that I can think about with my YouTube analytics. So I wanted to show that to you today. Let's see, where do I have it? Is it here? Nope, it's not that one. Okay, so here's my YouTube channel dashboard. And you can find various things in analytics. And let me show you a couple videos, analytics that are a little bit more interesting than the typical. So you know about how in the summertime there was this 3 blue, 1 brown summer of math exposition thing that I did. And I think I was one of the 100 or something finalists. At least I got a note to that effect. And my video is this one, the beauty of, I actually changed the name, the beauty of geometry of complex numbers and quadrilaterals. I initially said the beauty is in the proof, but decided maybe this might get a little wider audience. Anyway, the analytics of this one's pretty interesting in that the views started off fairly low. I uploaded it on August 21st, higher than most of my videos actually, even though it looks really low. And then all of a sudden in mid-October, early to mid-October, the views went way up into the thousands. So I was getting like a few hundred views a day, at least I think here. Actually, that day was like 700 views. But now it's tailed off since then. So this is actually somewhat typical of what happens with many videos, is they get a pretty little bump at the first day or so, and then they level off for a while. And then you might, if you're lucky, get sort of a little bit of an extra bump. That definitely doesn't happen with most of my videos, actually. This is sort of more of a lucky one, and also part of the contest, I guess that contributed as well. But it's sort of leveled off here as well. So that's a graph of the views versus time, and you can also see the watch time and the subscribers that I gotten from it. And revenue, yeah, I've earned some money from it, about $22 here in about, what's it been, 3.5 months or so. But if you had to relate this to calculus and you looked at that graph, would you call that graph a derivative or an integral? And when I say integral, I kind of mean antiderivative as well. Do you think it'd be better to interpret that as a derivative or an integral? Or do you have no idea? Any guesses? No idea? It is always increasing. Okay, just like the distance traveled function that we've been talking about is always increasing. You'd want to take the derivative of this. If it were a distance traveled function, you'd want to take its derivative to get the speed. Well, it's not a distance traveled function, but it's kind of similar. It's a cumulative number of people who watched, up to 8,200 or so now. If you took the derivative of this, what would that give you? The speed? Well, not the literal speed, but something analogous to the speed. This is total number of people. Its derivative would be number of people per day. And that's actually was the default view of these graphs up until recently, the last year or two, is instead of giving you the integral, it actually would give you the derivative. And you can still get that graph. I think if I click on this and go, since uploaded, it'll switch to a derivative graph. There's the derivative graph. So you see the rate of change, number of people per day, uploaded August 21st. Essentially that first day, almost 200 people watched it. 199 people per day. It's a rate of change. It's a discrete rate of change instead of continuous, because it's just saying that was the number of people that watched that day. But you could think of that discrete as it being a discrete approximation to a derivative. Then it went down. Second day was like 66 people a day, then 32, 33, et cetera. Then it was down in the, 10 or so per day. Then all of a sudden, yeah, in early August, it got up to 200, and the highest of my derivative value there was 662 people in one day on Monday, October 11th. And I didn't know what was going to happen. I didn't know if it was going to keep staying like that or not. But no, it's gone down. Okay. So now it went down to like 200 people a day for a while. And now it's gone down. It keeps going down. I'm hoping it's going to go back up again. It's in the 20, 30, 40s per day now, but so far it's not. So that's a pretty interesting one. Let me show you another one. That's also pretty interesting.
Man,
and not
is a
typical. Oops.
Beautiful part of God's
I did not
creation.
want that to run there. This is an AP Calculus prep video that I made. This was longer ago that I made this, back in January. Was this 2020 that I made this? I think so, yeah. And yeah, it was actually January 2020, okay. And it didn't do very much the first year. First year it got like close to 500 views. But then this last May, all of a sudden you can see it took off. And that's when the AP Calculus exams were in May. And there were like, last year with the pandemic, there were like 3 different times people were taking it, whereas usually it's just one time, I think. Early May, mid-May, and early June. And so I got these 3 spots where the views was rising pretty rapidly. So that is the integral. That's accumulated total number of views. The derivative, the rate of change, I can see as well. And there you see it's low pretty much for the most part, but then you've got these 3 spikes. Number of people per day is usually around 1, 2, 3, 4 to 10 or so. But I got these spikes, and like this big one here, that's up around 600 or 700 people that day that watched that. So it's pretty cool to think about the relationship between these things in calculus. And in fact, I even downloaded the data for this one. I downloaded the derivative data, this data here, in a spreadsheet. And let's see. This data is the views per day. That's the derivative value. I don't have the integral value in here. Well, I can compute it. I can make a new column, total views. So it wasn't part of the data, but in the spreadsheet, I can certainly compute it. For the first day, January 22nd, 2020, in cell F2, I can just click equals B2, and that's going to translate that number 38 over here. And then to get the data for the integral, integration is like adding, right? We do Riemann sums to approximate integrals, approximate areas under graphs with rectangles. We can add. This is effectively like a Riemann sum with delta t equal to 1. Take the previous total views and add on the next day's views like this. So I typed, if you can't quite see that, that says equals F2 plus B3. So it's taking the number, the 38 in cell F2, and it's adding the number of views in cell B3. So it's going to be 38 plus 22 is 60. And then if I click on this cell and click and drag the lower right corner, it copies and pastes the formula correctly to keep adding. So the next day I got 5 views, it went up to 65. The next day I got 10 views, it went up to 75. Then I got 5 more, went up to 80, etc. And I can keep going down the entire data list here. This was the year where I wasn't getting very many views on it. And then all of a sudden there's the large number of views in May of 2021 on the left there. You see the large numbers. Although none of those went up to, oh, I think an early one up to 600 something. And where are we now? December 3rd, 2021 today. So I'm up to that many views. And I can also get the spreadsheet to make the graphs of these things. So I could, for example, highlight this views column. Let's go back to a wider view here. Highlight the views column like this. And this is something, you know, I'm doing with my Google data, but my YouTube data, but you could certainly do on the job for various things. And it might be worthwhile to make graphs like this. So I highlight all those, I insert a chart, and it automatically picks the right chart, and look, it made a derivative graph for me. And I could do something similar to make the integral one. I could highlight column F. Like this, and once again, insert a chart, and I think it's going to pick the right one. Yep, there's my total views graph. That's my integral. Okay. So you get from the derivative to the integral by adding. How would you go the other way? How would you go from the total views back to the views themselves? Yeah, see how much was added each time. You could, with a spreadsheet, you could program it like this. You could go equals this number to start with, and then do a difference. Hey, derivatives are defined by difference quotients. That's not an accident that you would compute a difference like that to get the derivative values, the views per day. Okay, and I could keep going. And those numbers, oops, did I do that wrong? F3, oh, I know what I did wrong. Yeah, I did do it wrong. I got to do it like this. This number minus that number. That's the way to do it. And it's doing it for all of them. So then there's 4 that third day, and 10 the fourth day, and 5 the fifth, etc. Okay. So it's kind of, you might call this discrete calculus. There's no limits. We're dealing with discrete quantities, discrete functions, you might say, sequences. But you can still talk about the concepts of integrals and derivatives with discrete data. It's not the same thing, but it's similar. Okay. Pretty cool.